So,
Quadratics, it's chapter 3 from this book. Now this is a bigger chapter than before.
it's actually humongous.
It is indeed.
They do this in GCSE, quite a lot of it in GCSE, nearly all of it actually, in like 6 chapters, and it's in one A level, so...
We're going to have to be quite quick.
So here we go. So, what is a quadratic? So we've done expanding, we've done factorising, using x squared, and that's what a quadratic is.
Yes.
But what if you're looking at on a graph?
Well, you could draw a smiley face.
You don't need the eyes.
You don't need the eye, they're not part of it. Or you can draw a sad face and they look like that.
They do. And the difference between these two are the smiley face will have a positive coefficient, that's number 4x squared, and the sad face will have a negative coefficient.
And then these two definitely would have plus bx plus c, and that means that it's not the most simple form, which just goes through 0, 0. It's been moved down, this one's been moved a bit to the right, its bottom point is here. This one's been moved up, it's also negative, and it's been moved a little bit to the right. So it will have these two things as well. So, parabolas. I think parabolas are in nature quite a bit.
I think they are, like sort of falls, planes go up and they go down. And...
In fact, if I throw this pen into the audience, it will follow a parabola.
Oh my goodness. Is she right? I don't know.
I'll check. Oh, I didn't even know pens could go that deep.
Oh, I don't think you can take it out.
Oh!
She'll be fine.
I'm sure
She'll be alright. They got angry women and paramedics, it's alright.
Yeah, they might have to get a few lawyers.
Anyway, yeah. So, in nature it happens a lot, so sometimes you get questions about that.
For example, cannonballs are an example exam papers like. They like firing a cannonball that might follow this parabola.
Yeah.
Then they'll give you the quadratic of the parabola and stuff like that.
Yeah, it's just adding real life situations if you live in 1670. So,
yeah. If you happen to be doing physics, by the way, parabolas would be a very useful thing to get your head around, because in there they actually will ask the maximum height the cannonball will reach, and you'll be using this.
yeah, and that sort of stuff we're going to go through a bit later when we do complete square, but first...
Let's do a quick revision of factorising and expanding different types of brackets.
Absolutely.
So, 2x, x plus 3. That's one type of expansion you might do.
It is one bracket, it's quite easy, we'll go through it quite quickly. So we do that, type out all the things in a bracket. So the first one be 2x squared.
As soon as it's got an x squared, it's a quadratic.
Absolutely, and the second one will be plus 6x, because you times it both by that bit and that bit.
No, it doesn't always have to have a plus c, it doesn't even always have to have this part. If it's got a squared, it's a quadratic. So,
absolutely.
Second example, 2 brackets I'm sure you're familiar with, we're flying through them. We use foils.
We do, so first, whatever order you want to do, but essentially that times everything, then that times everything.
Yeah.
So we're going to have x squared again, so first 2, then we're going to have plus 2x and plus 3x.
Plus 6.
Plus 6, which will boil down to x squared, plus 5x, plus 6.
So it's always good to put it in its simplest form, and then that's expanding.
Now if we're going to factorise, we can use this example again.
Yeah, we can just do that.
We need 2 numbers that will times together to make this number, and add together to make this number.
So what I like to do is put a little thing to myself, put the number 6, and all of the factors.
So you have 1 and 6, make 6.
1 add 6, or 1 minus 6, 6 add 1 and 6 minus 1, none of them. Well, no, one of them would make 5.
But we'll have the wrong signs at some point.
So it wouldn't make plus 5, it would make minus 5.
Or it would make minus 6, depending on how you did it.
So that wouldn't work.
And then we have 2 and 3, which does work straight away, both with pluses, so we can do that. And that's what is up here.
So you just put x plus 3, x plus 2. Now this one's slightly different. You can take out a common factor. You'll notice 2 goes into both 2 and 6.
Yep, and x goes into both of them as well, so that's what you remove.
And then what would go in the bracket to get to 2x squared would be x, and to get to 6x you'd have to times by 3, and then you'll realise we've got what we started with.
You will. Now, that's the equation form. What happens when we look at it on a graph?
Well, we have translations. I'll rub this one off. We could take this one as an example if we wanted to draw that one.
So we always have an axis.
Yep.
And like I said before, the most simple of all quadratics is one that does this.
And that is y equals
x squared. So there is no x and no constant.
No, it just goes like that. It goes, they will touch 0, 0 exactly.
It would.
And it would go up equally either side of the y-axis. But this one has a plus and a plus, so what do we do?
So we have to look at a few things. First, we can look at these two, I think,
Yeah.
and what they mean.
When it's in this form, you can find out when the graph will cross the x-axis.
And remember, this is when y equals 0. So if y equals this,
If I plot it up here, I'll do it in red. We'll do it all in red.
Alright.
The black one's y equals x squared. So y equals, we'll put the full form up. That's how they'll give you it in the exam.
Yeah.
X squared plus 5x plus 6. You'll be expected to factorise it
yeah.
yourself. So we've already done that. It's x plus 3, x plus 2.
Now we want to make it so that equals 0.
So either this bracket will equal 0 or this bracket will equal 0.
And that's because when you times one by the other, you want it to equal the sum of 0.
So if x plus 3 equals 0,
Then that will equal 0. Or if x plus 2 also equals 0, that's not finished. You want it to just be x equals, you take the constant over, so it becomes x equals minus 3 and x equals minus 2. Now these are the 2 points it crosses the x-axis. So you could
minus 3 and we've got minus 2.
Now that gives us a rough shape, but we don't actually know when it goes through the y-axis.
No.
So you do the same sort of thing reverse. That's when x equals 0, and that's easiest to do up here.
So if x equals 0, x squared is 0, 5x is 0, then you've got plus 6.
So it must go through, let's say, that's 6.
Before we did this stage, we could have, you know, it's going to go through both these points, so it could either do something like that or something like that. Positive coefficient of x squared is true.
So it's a smiley face,
So it
and
must have gone up.
this is also confirmed by where it goes through
Just
this
like
point.
that.
And often you will have to do this, they'll say, draw it on and write where it crosses the axes.
This is all very useful stuff.
Then they start being a bit mean. They start moving around the graphs.
This is called translation. It's a
Transformation. Yeah, type of transformation. And translation is just moving it around as opposed to stretching it and doing odd things.
And at AS, translation is all you're bothered with. You don't need to worry about reflection or stretching or anything like that at the minute.
Certainly not yet.
So,
we do this using vectors. So a good one to think about, I guess, we can use the one we've already got, and how this one becomes that one.
yes, and we do this by completing the square. You can look at the graph when you're really good,
Yeah.
but I think as an explanation in a revision video, we'll complete the square, then you can work out your vector.
Yeah. So like Wayne said, we could do it just by looking at it, because we know it goes across that much and down so much. But this becomes clearer if you complete the square. But what is complete the square?
Well, it's putting this quadratic into another format, and you do that using the method called completing the square.
This does have a formula. You can just remember how to do it, but we like using formulas because formulas are cool.
So we'll just write it up. You're going to have x plus b over 2a
Yeah.
squared minus that b over 2a squared plus c.
Now you need to know what all these letters stand for because it's very important in quadratics. A is the number in front of x squared, the coefficient. B is the number in front of x, and c is the constant at the end, which it often is.
So it goes a, b, c if you put it in the right order.
Yep. So now if we do this with the equation we have,
Yep.
we have x plus 5 over 2, because it's 2a, and then our a is 1, minus that squared plus
Squared.
6.
6 is our c.
Yeah.
So that's that. We'll keep putting it in its form, so we'll put it a bit bigger now so you can see. You've got x plus, now 5 over 2, you can leave it as 5 over 2, you could also put 2.5.
Yeah, you could do a mixed number, but 5 over 2 I think we'll leave
I'll
it
leave
as.
it as that. That's normally the best way to do it, just leave it like that.
Alright, then minusing a squared fraction, so you square both the top and the bottom, so it's 25 over 4, which doesn't simplify that nicely either.
No, it's 6 1/4.
It is.
I'll leave it like that this time just so you can see it, 6 1/4. Then we're going to plus 6, which is our constant, so it boils down to something a little bit easier. So the final answer here is going to be x plus 5 over 2 squared minus 6 1/4 plus 6 1/4 is just
A quarter.
minus a quarter.
Yeah.
Now this is useful for our vectors, that's what we're doing this whole thing for. Now, this is what it's been translated by. You actually have a lot of information here. Now, a vector, as you're aware, or should be aware, is in square brackets. You put your x on the top and the y on the bottom.
Yeah.
Your x is how much it's moved in the x direction, is the opposite to what's in here. So your top number will be negative 5/2, like that. Or negative 2.5 if that's the way you wanted to express it. And then on the bottom is your y. You don't change the sign here, it'll just be -1/4.
Yeah.
And that is, you say, a translation by vector that.
And this isn't, and this applies to one point, it applies to your minimum point of the graph. That's the part that's moving this much.
Yes.
So it will move -2.5, so it'll be about there, and it will move down 1/4. And then you can say the coordinates of that point, as it moved from x squared, will be those two things. But it's not always, because sometimes you move from a different graph. And then they'll ask you what the minimum point is, and that will be that. They might also ask you what the minimum value is.
The minimum value is essentially the distance on the y value only.
It is.
So in this case it's
Just -1/4.
Yes. So every single point on this y equals x squared curve has been moved that much to the left and that much down.
But it's easiest to think about it being the bottom.
The lowest point, which is going to be here. And that's completing the square, and that's what it's for.
Yeah.
It might ask you to find the vector, in which case you complete the square and use this. It might give you the vector and say put it in completed square form.
It might well do.
Opposite of the sign of x, same for that, and you write it in that form, you should be familiar with.
Yeah, we are running through this quite quickly, but it's revision, so that's what it's for.
Yep, you can ask us questions, feel free. So we go on to more stuff. We've got the quadratic formula,
Yep.
and then the discriminant.
So I think there's a lot to rub off, so we'll just quickly do that. So I think we'll cut the take here and then move it back.
Okay.
So you left early, so you actually wanted to check on the woman that Wayne assaulted with a pen, and she's fine.
She's fine.
She's really okay.
She's not bleeding.
No, no one was hurt at making this video.
Very much.
A little bit.
Should we get on?
Yeah, we should get
Is that
on.
all right?
Right. Yeah.
Yeah.
Lawyers were sorted. We got very helpful snails on board.
Yeah. So, the quadratic formula. Now,
Sometimes
I would adapt it to your memory, but it is in your book.
it is, and well, we use it. You can't always factorise.
Yes, like when we did the two brackets and then you find out what x equals 2. If you can't do that, it might be a horrific x value, but
Yeah, it
now
might
you're
be
expected to know how to
Crazy
do it.
fractions. But you can do it with a really snazzy formula.
X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, that seems horrific.
It does seem horrific, and it is a little bit, but it's really handy, and it's much less horrific than trying to work out how to factorise with fractions.
So,
Again,
in your booklet, I would remember it.
A, B and C mean what they did before.
Yep, so always put it x squared, number of x, constant, then it's
Yeah.
a, b, c.
Absolutely. So now we need an example to put in here.
And I have a lovely one.
Alright. I need a red pen.
2x squared plus 4x minus 1 equals 0.
So-
Factorise that and find the x coordinates of where it crosses the x-axis.
Well, we're going to factorise, we're going to put it into this form.
Yes.
So, our x will equal, you ready, -4,
Yep. Or minus b. Plus or minus, that means you do it first plussing, then you do it minusing.
because you want to have 2 points, it's going to equal. So plus the square root of,
b squared is 16, but we'll just leave it as b squared at the minute. Minus 4 times 2 times minus 1.
all over
2a, which is 4. So,
right.
x equals minus 4 plus or minus. Now we'll simplify what's in here.
It will. So, like Wayne said, that's 16.
Then you've got minus 4 times 2, which is minus 8, but then times minus 1. Careful of your minuses and positives, that
That-
becomes plus 8.
It does.
So, it'd be
So,
root
60.
24
Yeah.
altogether. And
Over 4. Now, can we simplify this third?
You absolutely can, Triv, and that's using our surds chapter. If you haven't seen that, it's the chapter before this, chapter 2. Check it out if you don't know how to do it.
So you may need to. So here we
you
can.
Root 12 and root 2 wouldn't help us whatsoever.
No.
So I would go for root 4 and root 6, because that is simplifying it, because root 4 can be
Is-
broken to 2.
Yeah, so using our rules, we'll just skip through it a bit here. Be -4 plus or minus 2 root 6 because the root 4 would become 2.
Over 4.
Now we
So,
could simplify this even further, but I don't think we will.
don't have to.
So now we have to do both the plus and the minus. So we're going to do plus first. So minus 4 plus 2 root 6 over 4.
Yep. That would be one of your answers.
And your other one would be minus 4 minus
2
2
root
6.
6 over 4. Now you can simplify that to just minus 1 plus a half root 6.
You
and
could.
minus 1 minus
Minus
a half root 6 if you wanted to.
Yep, and these would be your 2 points of, say, an intersection.
And then you'd be expected to know which one's high and which one's lower, so which would be where on a graph if you were expected to label them.
And you can see straight away why, if you try to factorise that, be mad.
Yes, because there's no way you'd guess that to put in your brackets.
No. But why do we actually solve for x?
Well, it's to find where it goes through the x-axis, but sometimes it don't. What if I gave you this example
Alright.
and said find where it crosses the x-axis?
I think I'd struggle and I died, Wayne, because it doesn't.
So how do you know, without doing all of this and then going, oh, it doesn't work, how would you know if it crosses the x-axis? Is there some kind of shortcut?
There is a lovely shortcut, it's called the discriminant. So if you rub all this off. I don't need that. We do use part of that formula. So the formula for the discriminant is,
Just the bit in the root sign,
yeah,
which we can actually put in the top right, but we'll write up again anyway.
b squared minus 4ac. There's a couple of rules for this one. So that's what we do with our equation. We use these numbers, and if it equals a couple of values, it means different things. So if it's equals 0, it will touch it once,
So it might look,
like the most simple graph of x squared.
it could also have been translated, but it'll touch it just once. It would just
Yeah, it would just,
touch it. So now if we do it in a different colour,
like prodding over a stick.
for another one. If b squared minus 4ac is greater than 0, if you get the answer 1 or more
Yeah,
when you do this, then it means it touches it twice.
so it might go right below it,
So it just has 2 points of intersection.
like our first
It could
example.
also be a negative and still have 2 points of intersection.
Yeah,
But
both
it
one.
can be moved either way as long as it touches it twice.
Then lastly, as you might expect, it will be, if that is less than 0, it'll be like Wayne's example he showed me a minute ago, where it was above the x-axis and it doesn't touch it at all, or below and negative.
Yes, so it could be something like that. It could even be a negative one, as Triv just said. As long as it doesn't touch the x-axis, it'll be less than 0.
Absolutely.
Your B, A and C mean the same as they always do with a quadratic. And now I think it's time to do a test yourself.
I think it is, go on then.
Alright.
Question time.
Test yourself, page 53, question 8 from this book.
Except not quite question 8.
In fact, question 8 plus a clever cracker 2.
Yes, because we're going to use everything. We just rushed out a discriminant, so we want to add a question about that. And we're going to draw it. We're going to use everything they can possibly ask you in a quadratics question.
Yes.
So, we should start good place.
Good fun.
So, it says solve the equation 2x squared plus 32x plus 119 equals 0, and write your answer in the form p plus q lots of root 2, where p and q are rational numbers. Now that includes fractions, but not surds.
Right, I've got that. This is where we're going to add in our own little question. First,
Yeah.
we're going to do the discriminant. Now, it doesn't ask you to, that's ours doing
Yeah,
it.
you don't need to do it in this part of the question, but we're going to, and later on it'll help us when we draw it, so we'll know how many times it goes through the x-axis.
Yep.
So, as we went before, b squared minus 4ac is the discriminant.
That's a 2.
It is.
So, what we're going to have is
32 squared. Remembering that all of this, the a is part in front of the x squared, the b is in front of the x, and the c is the constant. So, this is a bit harder to do. So 32 squared is
320 plus 320 plus 320 plus 2 lots of it, which is 64, which is
1024.
2101.
Yeah.
Yep, 1024 minus 8 times 119.
Which is also quite awkward. So 800 plus 8 lots of 10 plus 8 lots of... Yes. So that's 952.
952 indeed. And you can tell without actually doing the maths that that is greater than 0, therefore it will have...
2 intersection to the x-axis, which is cool.
because we didn't do an example of this, we felt we needed to.
Yep. So now we go on to
The actual question.
the actual question, which is solving it.
So if the coefficient is above 2, there's no quick way of factorising into brackets.
You can, but it's a bit of trial and error and just take a while, so I'm going to do that. I'm going to go straight to...
These numbers are so big as well, that would be even more trial and error.
It would.
So,
Straight to the formula, which is x equals minus b plus or minus square root of b squared minus 4ac over 2a.
so ABC, as always.
Yeah.
You've
I'll
got
write that on for future reference.
x equals minus 32 plus or minus the square root of. Now, thankfully, we added our own question that did the b squared minus 4ac.
And that
So
gives us
that's
a value, so it's your
48 plus
difference.
24, which is 72.
Yeah, that's our difference.
Over
And over 2a, which is 4. Now, first step is getting rid of that surd. I don't want one. Well, at least simplifying it.
Yes, and we know it's going to get to root 2 because it says in the question. So if we divide that up into root something times root 2, that's
Adds
something.
36.
Yep, which happens to be
6, it does.
X equals minus 32 plus or minus 6 root 2. I've just taken that step for us.
Yeah.
Over 4. So our final answers for x, when you simplify
Yep.
this,
So when I get rid of that fraction, or at least split it,
32 over 4.
which is minus 8.
Minus 8, careful
Minus
positives
32.
and negatives.
And it'll be,
Plus,
there'll be plus and minus. We'll do plus first. And that'll be 6 over 4, which is 3 over 2 lots of root 2. And we'll have the negative version of that as well. That'll just be very helpful for the 2 points that we now know exist above a discriminant. Then it does go through the x-axis. But first, there's a part B.
Yeah, just for room on the board, I'm going to run out this work and we've just done. So we did talk through it, so we did it very quickly.
So, B has 2 parts, and that is putting it into completed square form. That wants it in the form 2 lots of x plus m squared over n. Now, that's all in brackets. So, we did miss a little bit when we spoke about the formula of completing the square.
And that little bit is if the coefficient of x squared is greater than 1.
Yeah.
Before we expressed it as x plus b over 2a squared minus b over 2a squared plus c. Now, there is actually an a here and an a here. That a is nearly always 1,
Yeah,
so
so
we left it out,
it doesn't normally matter, but here it's 2,
so it matters.
so it matters quite a lot. So, if we then put our values in, we have 2 lots of,
x plus
plus
b over 2a is 32 over 4,
which is 8,
and that's
squared,
squared. Then you've got
minus
minus 2 lots of this
same
thing
thing,
squared, which happens
which
to be
64 times 2 is 128. We have plus 119.
So we've got 2 lots of x plus 8 squared minus, as Triv said, 128
Yeah.
plus 119.
The difference of that is 9, so it's minus
Minus
9. Yeah.
And that is your completed squared form.
It did ask for these two to be integers, and they are. So that's good.
Part 2.
Part 2 is show the minimum value, and that's not the coordinate form, that's just the y value one.
So I'm going to write minimum value.
Very small parent, and that is minus 9.
Minus 9. Now, Hammer Cracker has added a 5th part to
Which
the
is often the most awkward, and that is drawing it. We have all the information to draw it, we just need to do it. So,
and in
x
exams
equals-
they may well ask.
Yeah.
So, okay, axis, as you asked so nicely.
I did. So, first thing to look at is it a happy face or a sad face?
It's a positive coefficient of x squared, therefore happy.
Yay!
We did this for you.
So it goes through 2 points, then it works out what the 2 points were. So we both have minus 8 plus 3 over root 2. 3 lots of 3 there.
3 over 2 root 2.
Thank you.
And minus 8 minus that. Both of these are negative because if you add 3 over 2 root 2 to minus 8, it's still negative.
Yeah.
This one is even further so.
So they're quite close together, relatively.
Now, where does it cross the y-axis? We haven't yet worked it out.
We
but
haven't
can.
yet, but we can, because when this equals 0, it will just equal 119.
So it's very, very high.
It's quite a steep one. And you also have the minimum point, which is in coordinate form.
If we have a vector of a translation, then you can express all of the things we've done today in this
Yeah.
video. The top number is x, which is the opposite of what's in there. This 2 has no impact on
It
it.
doesn't.
If it was
still,
here, which it never is, but if it was,
if it
then
was there,
it
then
would
you'd
do
half
different.
it, but you don't in this example, as it becomes minus 8
And the bottom
over
stays the same.
minus 9. And because it's a change from x squared, that's actually the coordinates down here.
So,
Of our minimum value, minimum point, sorry.
that's a curve, not a V, I promise.
And that does go through here, honest.
It does. Very poorly drawn. Minus 8 minus 9. Which looks right, minus 8 is going to be in the middle of that perfectly, because it's symmetrical with that. So that is a curve, and it does go through the point 190.
Yeah, not that one. And it does go past the x-axis at 2 points.
And you could label those points on as well. It's
You
going to be
could.
quite awkward for me to write on a board.
But you could label those. Now, this is probably the hardest question you'd ever get, so you probably wouldn't get this one.
No, but made it evil on purpose, so you know what to do if it is.
Yeah, and if you have any other questions, want to cover more, ask us on our Facebook page or comment below and we'll try and get back to you.
And we'll see you there.
Absolutely, alright.
Crack on for a cup of tea, I think it's deserved.
Oh, that was a very long video.
It really was. So, quadratics. There's quite a lot of stuff in it, which is why it was long.
Yeah. So we have the equations, you've got expanding them, factorising them, which should be quite used to by GCSE.
Yep.
That's a good thing to practice a lot of and get quite quick.
It's very good at being quick, especially expanding more than factorising.
Yeah.
Because factorising you tend to have to use the equation.
Often.
Often.
Occasionally they ask you to factorise it and it might be a higher coefficient than 1, so it's good to practice that a little bit, but it's mostly trial and error way of doing it.
Yeah. I don't like doing that. I personally like to use the quadratic equation if the coefficient of x squared is greater than 1.
Yeah, I also. Then we have the actual graph, and what the when you solve actually means. It's the where it hits the x-axis, if it hits at all.
Yep. It's basically making y equal to 0, but you do that by factorising or the quadratic equation. If you want to find your y, you make x equal to 0.
Which will mean it's just the c constant at the end, if there is one.
Yep. Finding the minimum value is completing the square. It's a method of expressing it in a different way.
Remember, that's a big equation.
Yes, remember the a in front of it as well.
Which we did.
A lots of x plus b over 2a squared minus a lots of b over 2a squared plus c.
Yeah, it's quite an easy thing to remember because it's just getting rid of the thing you create inside the bracket.
Yeah.
But, yeah.
That's how you define it in another way, and then that's all about translation. So the vector, x is on the top, y is on the bottom. X changes from in the bracket, y doesn't change its sign.
Yeah.
The number in front of the bracket, if the coefficient of x squared is greater than 1, does not affect the number when you take it out and put it into.
No, but if for whatever reason the x is on the inside, say if you factorise something with a coefficient higher than 1, it'll halve the value that's inside of that bracket, in particular if it's a 2.
Yep. I think that's pretty much that over.
I think they have discriminant, but you know what that means.
Yeah, discriminant, remember discriminant. It's just b squared minus 4ac, and I think that's it.
I think that is. I think I need a cup of tea.
Oh, I definitely think you do.